This guy always late actually. Nabil, I mean, he corrected himself, but not the Ghazanfar yet. Nabil, are you there?
Yes,
Nabil.
sir.
So, I mean, how about your submitted journals? I mean, did you ask anything from the editors or something like this? The first one, especially.
I have sent the email.
Mhm.
Not got the response, maybe due to weekend or something. But I have sent the mail.
Mhm. When it was submitted, actually?
8th of July.
4th July. 4th.
8th of July.
Okay.
Mhm.
4 days. But they
4th,
have 30.
4th of July.
Yeah, they have 5 weeks, I think, for a first decision. So I thought, because last time they have forget our article, and after 20 days they have saying we did not find the reviewers. So they have just sent the request, or after 15 reviewers, our article just got into the reviewer state. So sometimes they forgot to remind the reviewer that what you will accept or not. That's why I said him to
Okay.
check.
Oh, okay. I'll
Nabil, can you call to Ghazanfar?
Yes, sir, I
okay,
am
sir.
here.
You are here now. Okay.
Yes.
Okay, Mudassar.
Okay. The article which the Ghazanfar just shared, I tried to reproduce the result which were given there for a circuit which he have already designed, and I also go through the paper which we were just trying to follow up. I have just reproduced the result like for 2 times amplified signal, and this is for, you can say, 10 to 11 times amplified signal, and then I've also tried some AC analysis to see how the, because we are just working for a 1 kilohertz, so I try to see different results which we can so you can say add in our paper, so we can make it more, you can say, authentic. So I just simulated different results, but the problem which I am little bit facing is that the 3 circuit which is given in our, you can say, article, that is okay, that I have just already reproduced for 100 times gain as well. It will also be done today. I can simulate all the results. But my problem is that after that, what is the final thing we want to do? Because after reading the article, which is provided, they have a circuit, but their values are missing, and it is also in a, you can say, bit and pieces. So I was little bit confused
Yeah, I
what we
mean,
want to achieve
yeah.
at
Did
the
you
end.
did you follow mine actually, which I make a rough kind of manuscript?
Yeah, there was some plots missing, but
Yes. Yeah.
there was you can say, caption are were there, but because I don't know electronics that much, so I need to see for which part, for which, you can say, the body plot I tried to simulate for the 11 times gain. I was
Okay.
getting something like, I don't know what was that, but I was surprised that we are taking different small circuits. At the end, at least we want to maybe combine them for a large circuit or whatever. So what is that? So I can simulate the graph for the which are missing in the manuscript. So I'm little bit.
Yes, I mean, yeah, definitely you are confused actually.
Yeah.
Because I was waiting some results. So after that results, I was thinking to conclude what exactly we can
Yeah.
show. The thing is actually local amplifier. Okay,
Yes.
so this was actually main thing. Zanfar, come up.
Yes, yes,
What
sir.
what do you say about Madassar saying? You also have some results, isn't it, regarding this thing?
Yeah, I just reproduced his results, the which he have already produced in the manuscript. Now the result are missing. For which circuit those need to be, you can say, simulated, or what are the purpose purpose to take the small circuits if we want to combine them at the end, or what we want to do. That is my main problem right now.
Okay. Mudassir, I am too a little bit confused about the results. Actually, the main idea which I understand is we have to make a signal which whichever our main signal coming from the amplifier, which we amplify around, I think, 22 times than the original signal. So we have to uh, uh, take out this main signal from the noise. Now the problem which I am also not understanding is the where this noise come from and how we can generate this noise. This is the main problem which I am also facing, and I am working on it, but not get much information.
Okay, do
Yes.
one thing. Okay, both of you do whatever results you people are having. Okay, along with the circuit diagrams, you people need to send me. Okay,
Okay.
and make a PPT file and little explanation down whatever you got actually, whatever what kind of pattern, what kind of transient analysis. Okay, and send
Mm.
me. Okay, so I will conclude that article. Zanfar, I think you
Sir,
have done something more, maybe, isn't it?
sir, we have already just we done the amplification part.
Okay, okay.
We achieved this amplification part, which is required according to the according to article. So the main problem which which I am facing is the where we will get the noise signal, and
Oh,
and then we have to give the ratio. I think this is already mentioned in the article too.
yeah, because lock-in amplifier, basically, this is a basic theme of
Yeah,
the lock-in amplifier.
yes,
Okay.
yes,
Okay, so
yes.
at the moment, I mean, you can send me whatever you have, or it's the same which you sent me last time, or you have something more.
Sir, I have the same thing. I have no laptop, so I
No,
just
you were saying you something you want to draw some like region, some plots or something like this. You were saying like this last time.
sir, this is the same thing.
Okay,
Just I want to draw in the amplifier. We have the middle section of the band pass filter.
okay,
So we have the plot of this band pass
okay,
filter.
okay. Okay, so Mudassar, whatever you got here, you can just send me in the PPT. Okay,
Okay, I
and
will send, but it is just the same result which is given in the already in a manuscript. I just reproduced them in the
yes,
form of
I
form
will
of
see.
graph.
I will see what further
Yeah.
can be done and
Mhm.
what cannot be done. Okay,
Okay. Yeah.
so I don't want to spend. I mean, I don't want you people to spend too much time on this thing actually.
Mhm.
So that's all. Okay, now Zanfar, you start your presentation, which you are supposed to.
Okay, sir. I will share my screen. Can you see my screen?
Not yet.
I think
Okay.
now the screen
Yeah.
is shared.
Yes.
Okay. So
Now make it full actually.
okay. Okay.
Okay.
Is it okay now?
Yeah. Okay. Go ahead.
So, okay. This is the just review of the my MS project, which I done in my MS final year project. So, the main title of my thesis was the design and development of a laser beam collimator to overcome the beam divergence with respect to distance. So, this is the main system architecture. As you can see in the figure, we have this green diode laser, and this is the primary laser which we want to control the divergence. So this green diode laser work around the 532 nanometers. So this will pass to the plane Max, whose focal length is around 27 centimeters. So and fall on the target. So this lens is mounted on the motorized stage, which is around 9.8 centimeter. And this motorized stage was controlled by the stepper motor, and this stepper motor was energized by the TB6560 motor driver, and these motor drivers controlled by the Arduino Nano. So the motor actually work on a 12 volt. So we have the uh, additional adapter to provide this provide the voltage required voltage to the motor so that it can run. So on the top we have the other stage, which on the front we have the red pointer laser. uh, I will explain why we take this red pointer laser. Then on behind we have the MPU 6050. It is the sensor which detect the motion and tiltness and the angle. So on which is connected to the Arduino Nano, and its work on the 3 volt. So this 3 volt is provided by this Arduino Nano uh, as a voltage. So this Arduino Nano is controlled by work on the 5 volts. So this 5 volt is provided by the system or the laptop which we have connected. So what is the main purpose of this design? Is to control the divergence. As we move this target further apart from the lens, you can expect the divergence. So the main goal is to keep this dia constant. So as I already mentioned, you that we want to control the divergence with respect to distance. So to calculate the distance, we have actually make the triangulation method. So in this method, we have to virtually form a triangle with respect to this green, red pointer laser. First we have to align this system, green laser and the red laser. Then after moving this stage on which we have the MPU 6050 and Arduino, so it will calculate, it gives the tiltness or the angle. So by using this angle, we can use simple trigonometry and calculate the distance. In our case, we have the base distance. Base distance is the distance from the red laser and the green laser, which is fixed 22 centimeter. So by using the trigonometry, tan theta is equal to 22 by d, and d is the distance with respect to the green diode laser. So we want we get the results, and on this side you can see we have the draw the result with uh, which prove that whether this system is working all right or it's have some bugs. So first we have the draw the graph between the actual distance and the measured distance. Measured distance is the distance from the triangulation method. So as you see, the plot is the linear, which shows that the actual distance and the measured distance are same. So we can use this actual measured distance from the triangulation in our calculations. So for that, we have to first draw the graph between the divergence or the diameter of the beam and the actual distance. So we get this data, and from this we have this linear graph. As you know, the basic equation of linear graph is y is equal to mx plus c, where m is the slope. So and c is the y-intercept. So by using the origin software, we easily determine the this slope and the y-intercept, and we can write this equation with db is equal to 0.1178 dot d minus 7.876. So this capital db is the diameter of the lens, diameter of the green laser, and d is the distance from the green laser to the target. In other, we draw the graph between the rotation of the stepper motor. We take the rotation along the y-axis and the diameter of green laser along the y-axis. Again, we get the same linear graph. So by using the equation and by origin, we can determine the equation. So by using these equations to dB and dB for the constant
Ghazanfar,
Yes,
this
yes, sir.
rotation of stepper motor, I mean, what are the units here?
So these are the actually we calculate the orbitary. It's the just the one complete rotation. For one complete rotation, we get the diameter.
Okay, 2, 4, 6, 8, 10, and 11.
Yes, yes, yes. So the for the constant diameter, you can equate this equation, and we get the relation between the rotation and the distance. So this rotation is controlled by the stepper motor, and distance is the distance from the green laser and the target. So by using this equation, we can write the program and code for which we can control the system by systematical way. So this is the flow chart for the my Arduino code. So as we start the system, first MPU 605 calculates its offset. So how actually its work is that when the initial position of the sensor is taken as the reference point for the MPU 6050. So from there, when you started the system, so small rotation or small tiltness or small anything will measure with respect to its original position. So when it calculates its offset, then the loop will begin, and it will gives the angle, and this angle will convert it into the distance by the triangulation method. As we push the button, it's in our control when we want to uh, when we want to control the dimensions. So it's just for that purpose. So when we lower the button or push the button, then the system will go to the uh, code and calculate the distance for which it will rotate. For example, as we for our in my experiment, we uh, take the diameter 15 centimeter. For that, we have the two distances ranges. One is from 100 to 200, and other is 210 to 650 meter. So it just ranges. These ranges are just because uh, if if the diameter is less than the 15 centimeter, then what we want from the stepper motor to do, whether to rotate in clockwise or anti-clockwise. So it's just for that. These ranges may be changed according to the diameter. So when the range is between the 100 to 200, then the stepper motor pin will be low, and it will rotate in clockwise direction. So and if the distance range is between 200 to 650, then its will pin will get the high, and will the stepper motor will rotate in clockwise direction. So after this, when it's reached its final position where the die is 15 centimeter, then it's stay for the 8 second. Then the stepper motor will get back to its original position where it starts. So in this way, the at that point the code will be exited. So this is the actual uh, system, a video of the system. I can play. You can see. So this is the actual
Which
system.
which is still
Can
classified? Ghazanfar is still classified?
sorry, sir.
Still classified?
No, sir. This system is I don't go went to the lab, so I don't have this status.
Okay, continue.
So So this is the green laser, as you see, and the pointer laser. And this is the target. It's actually 15 centimeter, as you can see. So as the distance between the beam and die decreases, so the diameter will decrease eventually, as it's still linear. So its diameter will come to 7 centimeter. So I will rotate the red pointer laser to the mid of the green laser, as you see. Now, as you can see, the diameter will increase to the 15 centimeter. So now we just increase the distance between target and laser, so the beam die will increase. So it's increased to the 23 centimeter. Again, the procedure will be repeated. Then you can see the dia will start decreasing to the 15 centimeter. So that's the video. And that's all.
Ghazanfar, can you hear me?
Yes.
Yeah. Okay.
Yes, sir.
So yeah. Okay. So I know about it. We already submitted this article on this your experiment. How you can improve
Yes.
this setup?
Sir, we can improve by using the little bit confined system. So as you can see, this is the little bit bulky. So we can improve by using the little bit confined way, and uh, also maybe we can use it the distance between the actually the main problem which I facing when I doing this experiment is the alignment of the red laser and the green.
Mhm.
So if we fix these two lasers, or we can we as you see, I execute the triangulation method by the manual way. So if we make it motorized, so maybe it will be improve our efficiency of the laser.
Yeah,
Can we make it more compact?
Yes, sir. We can make this more compact by using the uh, less size motorized system.
Mhm.
but I think one thing which we need, we can improve that the way he is asking the laser, red laser, which we are adjusting manually. Can if you can make that through the Arduino or something like sync with the green one, so that can be a better thing, because every time you cannot do the manual if you want to.
No, say it again,
Uh,
Mudassar. Say it again.
I'm saying that
Yeah.
the red laser which he was saying,
Yeah.
so he was doing manually. So if we can have something like that, we
Okay. Okay.
put a mirror or something that he can adjust the angle of elevation by himself
Right.
using the
Program through
Arduino.
Arduino. Through Arduino.
Yeah, so it can be a good
Yeah,
thing,
it
and
can be a good idea actually.
make it compact. But just for that, we need to synchronize it to the Arduinos. We can place them together. That will not be a problem, I think.
Mhm.
If
Yes, Ghazanfar.
can you, sir, the which I understand from the Mudassir is we want to saying that we take the red laser and place on the green top on the green laser,
Then
so
they
that
synchronize. Yeah, they can elevate the red laser elevate by himself by following the distance.
नहीं किया नहीं है, झूठ कह रहा है
प्यास साहब अपना माइक बंद कर लें,
सर। मैंने
वो आवाज आ रही पीछे से आपकी। Okay, Ghazanfar. So, Ghazanfar, where are you? You don't show your face today.
Sir, I can show you my face.
Yeah,
Okay, sir. Ghazanfar, I have a question to ask about the previous one, the beam collimators, right?
Yes,
Sir?
yes, sure.
So actually, like you said, like you designed the beam collimator, this motorized system for so the lens you use is a spherical lens, right? So this I think it's
Okay.
rather be a collimator or it's rather be a beam size adjuster, because like the beam collimation is like have you seen like along the distances beam diameter? Did you check it along the propagation distance?
No, it's a beam size adjustment,
Yeah, it's
basically.
beam size adjustment, it's not a collimator, and it's like your size using a single spherical mirror lens. So it's I think it's you better to call it to manipulate the beam size, okay, with motorized channel. So rather than being is like the collimator.
Yes.
Collimator must like have a some collimator pair up two lenses, spherical and cylindrical lenses or whatever the telescopic configuration. So it's better to call it like so second is like if that is the case in the improvement point of view, the beam collimation is the most the one this the size is also important in like multiple of application, but like in most of cases when we talk about the laser application, the beam collimation is like important thing, okay, for the longer distance. So if this channel can be converted toward the beam collimator to control the divergence for the longer distance, then like you would have another perspective of this work to go ahead. So like this is my suggestions and input,
Yes,
like it's better to call this
yes,
beam
Fias.
size.
Yeah, I mean it's possible, but
Okay.
he cannot do this thing now because this was his master project. But
No, like
definitely it can be done.
extend.
Yeah, it can be
Yes,
done.
yes, sir.
Yeah,
Yeah, definitely.
by sure.
So it's better to call it size, not collimator, if it could be corrected.
The lens is not a collimator. The whole system is known as the collimator.
I wondered it couldn't be called collimator. That's okay.
Yeah, actually, this is
Basically,
not a
they are
collimator
taking
actually.
like
This
Yeah.
is
you can
the
say
lens is just
Mhm.
the lens just is the lens just adjusting the diameter of the beam.
Exactly.
So
That's the point. It's just
it's not the collimator. Collimation you have to be lens at the focal point from where the lens is light came from, and then the rays are parallel to each other. So this is the collimator. So the whole system is collimator. The lens is not collimator. So this is
This is
okay.
confusing.
That's fine.
This is confusing
Let
actually.
it.
This is confusing. Mhm.
And,
So
just let for the uh, like information. The collimator is just to minimize the divergence of the beam. Like let it very be simple for you students as well, like to understand. Okay, so that's it.
okay, Ghazanfar, thank you very much. And now you will be working on the next task, Ghazanfar.
But by the way, it's good work.
yes.
Thank you so much.
Thank you, Prayat.
Yeah. So Ghazanfar, you will be on your next task. Okay, you know that. Can you hear me? Ghazanfar,
Sir,
Ghazanfar.
yes, sir. I didn't. What you say, sir? Can you repeat?
You will be on your next
I
task.
didn't hear you.
You have to continue your next task.
Yes, sure, sir. Sure, sir. Sure. I'm working. I'm working on the metaphors laser. So I try to grab the knowledge as much as I can, and little bit confusion. But I watching some videos and reading some literature. Maybe we will do inshallah better.
Okay, second thing, this video actually I asked you before as well. So this video, I mean, I want to for my channel actually, that the gold channel. Is it possible?
Yes, sir, I can send you this video. Or you
Because
want some
before,
implement?
no, I don't want to implement as it is. I mean, I will just as it is what you have, because the last time you refused somehow, so I requested you again.
So no,
Yeah.
sir, I didn't refuse. I
Mhm.
just was saying that whether we have to inform our
It's
supervisor of
okay.
the
I mean,
vessel
it's
for
not a
we
so
are.
big thing. It's not a so big thing. I mean, it's just a simple thing. By the way, I mean, you have
Yes.
expertise in Arduino. Maybe I will also think to have some project related to Arduino. But at the moment, work on this femtosecond ultra-fast lasers, okay? And so that we'll see, I mean, how much you can grasp. And also
Okay.
the video which I shared you have to watch
Okay.
it carefully,
Sir,
okay?
sir, one more thing I want to add. Uh, as you know, I get this new laptop, so I install this Emacs, so it's work on this.
Okay, that's good, because David also installed and it's working there as well.
Yes.
So there
Right,
is
no
something, I
problem.
mean, related to these kind of things. Anyway, so thank you, Ghazanfar.
If you
Thank you.
Nabil, where are you, Nabil?
Yes, sir.
Nabil, also, I think I gave you another task as well, that Oslo.
Yes, sir.
Uh, I think you can do two things parallelly.
I'll try to do, sir.
Because,
Actually,
yeah, say.
I'll try to do.
And I want you to, I mean, prepare a short videos of Oslo. I mean, it will also help you to understand, and it may be beneficial for the people.
Okay, sir. First, let me learn the basics of Oslo,
Hmm.
and then I can move with the videos and stuff. Uh,
Yes. So, but please do it actually. Oslo is necessary somehow to have a variety in this group. And the
okay,
second
sir.
thing is that the ZMAX stuff you have to discuss with Mudassar intensively. Okay.
Okay, sir.
Don't care about his angriness. He's always angry because he's a Pathan. So,
I told you it's natural.
yeah, yes. So, I mean, you can uh, discuss with him. You can disturb him time by time. I think he will be happy, because that will be article.
Okay.
That will be a good article, I think, if you can do something with this your setup.
No, he's doing
Okay, sir.
really. He
Yeah.
coordinated maybe with me something. I already have
Okay,
a
sir.
lot of discussion with him. It's not a problem like that.
Okay.
We try to wrap it as soon as possible.
Yeah. Yeah. Only problem is the Nabil's timing. He
Yeah,
has very less
Yes.
timing. Okay. So you have to wait
that's the
for his
problem.
replies many hours
Yeah,
most of the
that's the
time.
main problem.
Yeah.
He usually reply after a week. In that time, I just finish already all the work. So I
Yeah.
just get angry. Why you
Yeah.
did not reply on time?
Yeah. Yeah.
After a week, you are
Yeah.
replying me.
Yes. Yes. Yes.
What we will do?
This is
Actually,
frustrating. This is frustrating. Actually,
Yeah,
this is a
actually,
problem.
yeah,
I
that's the
have a habit of
problem.
forgetting. Sometimes I open the text and I think I'll reply or I'll talk, and then I
Mhm.
forget.
Hmm.
And and the next day comes, and if by some mean I read the name of a person or it comes into my mind, and then I open the chat and like, oh, I have to reply him. Oh, I have, he said something. I have to reply.
Wow.
So this
Wow.
happens with
This
me sometimes.
it will be. I mean, for the other person, it's very frustrating.
Yeah,
You
Yeah.
know
that's the
that.
problem.
Yeah.
I
Yes.
was just
Yes.
stuck with the thing, so I don't want to waste the time because I already have a lot of work. So I have no like in the nature to
Mm.
leave one thing in the mid and go to the other. So I'm just little bit at that much. I have at that time I have a little bit
Yeah. Yeah. Sure. Sure.
splitting.
Yeah. Sure.
But I
Uh,
have some ideas, around 4 5 ideas. But as I said, if they can work on Zmax little bit more, so I can give them that idea because I already have some ideas
Yeah. Let
which are
him to
very good.
finish. Yeah. Let him to
Yeah.
finish this one,
So,
and
yeah,
probably
then
then
we
you
will,
can. Yes. But
yeah,
yes.
yeah, I want one of the person with Oslo as well,
yeah.
and
Oslo is also good.
yeah, and
We can try with
also
that.
yeah. David, are you there? He left.
Yeah, I think.
Hmm. Okay, so Fiaz Saab, do you want to add anything?
Okay, thank you very much, sir. That's all from my side. Like, maybe from the next, me and Mudassar will like continue with the this waveguide replacement with the micro lens array, and maybe the later this week I will share that manuscript as well with Mudassar and you. So like how to integrate this shaping system with the current
Mhm.
manuscript. So
Okay.
I think this is like all from me.
Okay.
Okay, okay.
I will send you the detail of the parameters, and then I will also write in the file what I want from you, which as much as possible. Then we will discuss in the
So
next meeting
yeah,
about that.
we will continue discussing on these points and do share that file, the one you just like presenting here, both the
Yeah.
ZMX file and as well the PPT. So like I can like go through that file and maybe later on I will discuss with you as well.
Okay. 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 No
Okay.
Oh,
problem.
thank you,
So
Fiasa.
good of you. Thank you, sir.
Thank you very much. Thank you, Fiasa.
Okay, okay.
Mudassar, I mean,
Mhm.
is it possible that on this platform, if we can have a short kind of, I mean, workshop on a Zmax, something like this, with Nabil? The
Uh,
Nabil I discussed already. Is it possible? Maybe you have a problem with the timing or something. Maybe you are
yeah,
busy.
I'm little bit stuck because my professor is coming back tomorrow maybe, so I'm little
From
bit
where he is
working.
coming?
He just goes to the goes I think in Ghana he has conference, so he has some
Okay,
little
okay,
bit on a single photon. So
okay.
he just came back.
Hmm.
So I'm working on a already manuscript, three,
Hmm.
four manuscript with him.
Hmm.
So just want to
Okay,
finish at least
okay,
one or two.
okay, okay, no problem.
So that's
Okay.
why I was
Okay, no
busy.
problem. Probably Nabil, maybe I will discuss with the Nabil, maybe if he can.
Yeah,
Yes,
I
Nabil.
can help him. I can help him, but I may not be able to participate.
Hmm.
That's why I'm not sure.
Nabil, are you there? Okay, so anyway, let's conclude the meeting. Okay.
Hmm.
So thank you
Okay.
very much. Okay. See you in the next meeting. Okay. Okay. Allah Hafiz.
Perfect.